Hey, hello everyone, welcome back. Let's talk about 10.3 derivatives of products and quotients. Alrighty, in this problem we are given an f of x and an s of x, and we want to know what the derivative of their products are. But in the instructions they say to not use the product rule, so this means that we should do some algebra before we take any derivatives, and hopefully that'll simplify things for us. Alrighty, so f of x, s of x, if we multiply the x to the 6 plus 1 times x to the 5th, see what happens when we distribute that x to the 5th, and we get x to the 11 plus x to the 5th. And then we can go ahead and take the derivative of both sides, because that's what we want to find is the derivative of the product. And so if we do that, I have a polynomial, so we can just use a series of power rules. So bring the 11 down, subtract the power by 1, and then add on the derivative of x to the 5th. So again, bring down the power and subtract the power by 1. So we should get 11x to the 10th plus 5x to the 4th. Alrighty. And that is the derivative of f of x times s of x. You can, if you're feeling adventurous, you can use the product rule instead of simplifying beforehand, and you should come out with the same answer. It's just to show that you could do some work beforehand and then take the derivative, or you can just get to the derivative instead. But anyway, for part B, we want to show the derivative of f times the derivative of s, that their product is going to be different than a. All right, so if we find f prime of x, the derivative of x to the 6 is just 6x to the 5th. Use your power rule. And then s prime of x, that's going to be 5x to the 4th. And so if we multiply them, let's see what we get. 5x to the 4th. All right, we get 30x to the 9th power, because we can add, we can add these two powers because they both have a base of x. So notice how these two aren't the same, and this kind of proves that the derivative of f of x times s of x may not always equal, and more often than not, will not equal the product of their individual derivatives. So let's do one more, now with the quotient of two functions. So they want us to do t of x over b of x with the given t and b functions. So if I do that, let's do x to the 6th divided by x to the 4th, and then we should simplify to avoid having to do the quotient rule, because that's stated in the instructions. To simplify x to the 6th over x to the 4th, you can subtract the powers, or you could also think of it as 4 x's canceling with 4 of these, so you'd have 2 left over. Whichever method speaks to you, just go with it. All right. So that's how we simplify t of x over b of x. And so when we want the derivative of t of x over b of x, we can just use the power rule rather than having to use the long quotient rule. So both of these problems kind of show that if you do small algebra work before taking the derivative, it might make taking the derivative easier. Now, if there are some situations where you are asked to use the quotient rule or the product rule explicitly, then I would use that instead. But I can't think of any, at least in this class, that you would need to do one method versus the other. So you can pick whichever way you like best, either do some algebra before or just go right into using your product or quotient rules. All right, and then part B also is kind of similar to the part B of the last question. We're just going to show that the individual derivatives, when we divide them, it's not going to be the same as what we found in part A. So we can find t of x real quick. That's going to be 6x to the fifth, and t prime. And b prime is going to be 4x to the third. So when we divide those two, right, what do we get? We get 3 halves, and then again you could subtract the 5 and the 3, that's from algebra, and get 2. So notice how these two again are not equal. So taking the derivative of a quotient may not and usually will not be equal to the quotient of their individual derivatives. Okay? All right, let's do some more examples. Okay, so I have f prime of f, I have f and I want to know f prime. So other than knowing this is what we're covering in the section, how would you identify whether we need the product or quotient rule, right? So one thing you could do is you could read the function out loud, which is something I always like to do. So if I'm reading this function, I have 3x cubed times, right, that's what the parentheses there means, may not always be written out, but there is times there, times x squared minus 3. So because I said that word times, and I said a function of x times a function of x, that should trigger you to use the product rule. All right, so that's the one we're going to use for this problem. Another thing I like to do is to label them. Again, extra work, but you can do what works best for you. I like to label them whatever you want, doesn't matter. And that will help me write out the derivative and the rule. So g prime, right, and then you leave the other one alone, plus, now you leave the one that you just took the derivative of, and then take the derivative of the one you didn't, if that makes sense. So I took the derivative of g here, and then left it alone here, and then I left h alone here, but I took the derivative here. So you're never going to have g prime h prime plus gh or some other version. So just make sure that you have the right formula. You can write them down on an index card for easy reference if that helps. Same for the quotient rule. All right, so kind of like how I did the previous problems, I like to do the derivatives on the side just as an intermediate step. And so I get 9x. We can do it together. So 3, that's a multiplicative constant. I'm going to pull it out. And then all I have to worry about is this x cubed. So it's got a power, so let's use that power rule. 3x, and then subtract power by 1. And I get 9x squared. Let's do h prime. So I have this x squared now. Again, power rule, so bring that 2x and decrease the power by 1. And then minus 3, so the derivative of minus 3 is just 0. And so h prime is 2x. So now I have everything I need to build out my derivative, prime of x. So I'm going to take the derivative of g, or what I call g, and that is that 9x squared. And then we're going to multiply by h, which I made the second term of the product, x squared minus 3. And then I'm going to add g, which is 3x cubed, times h prime, which is 2x. So multiply it all out. I get 9x to the 4th, right? Add those 2 and 2, and then I get minus 27x squared. And let's multiply these two together, 6x to the 4th. And I can combine these two like terms and get 15x to the fourth minus 27x squared. So I kind of just did both parts in one step. So this answer is going to be 15x to the fourth minus 27x squared. And then for the first part that I kind of skipped, we have to match A, B, C, D, which one matches our formula for our f prime. So I think if we look at it really carefully, I think C should be it. Right? I'm sorry, D. And so we notice that this term kind of matches with this term, and this one matches with this one, but it's okay that they're flipped because we have addition in the middle, so the order doesn't matter. That's not the case though for our quotient rule. Order does matter because we're subtracting the terms in the numerators. So that's just a little difference between the product rule and the quotient rule. All right, so D, and then this polynomial for this problem. Let's try another one. Okay, so we have f prime of x. And again, if I write f of x, I have this 2x to the fifth times x to the fourth minus 6. So two functions of x being multiplied, I need to use the product rule. I can't just take the derivative of this term times the derivative of that term that we found not to be equivalent. So we have to use our product rule. Again, I'm going to label it G and H. So f prime of x is equal to G prime H plus G times H prime G prime. That's just going to be 2 times the derivative of x to the fifth, which is 5x to the fourth. And so this simplifies as 10x to the fourth. H prime, I have x to the fourth. So that derivative will be 4x to the third, and then the derivative of minus 6 is just 0. So now let's plug what we just found in. 10x to the fourth for my g prime, h, which is the original function, x to the fourth minus 6, plus g, that's going to be my 2x to the fifth, times h prime, which is 4x to the third. So doing some algebra work just to simplify, because I think MyLab wants you to put it in the simplest terms, I believe. But it's also good practice. 60x to the fourth plus 8x to the eighth. Again, I have some like terms that I'm going to combine. Get 18x to the eighth minus 60x to the fourth. Alright. Now let's do some practice with the quotient rule now. So f of x is a quotient, right? You can kind of do the same game with product rule, is that you can read this function as x divided by x plus 20. Right, so when you say a function divided by another function of x, that shouldn't make you think, I should use the quotient rule. Because we found earlier that taking the derivative of the top and then dividing it by the derivative of the bottom, that's not the same as the derivative of the quotient. So let's use the quotient rule. I'm going to label it this way, GH. You could write it top, bottom. The letters don't matter. It's something that we're defining. But whatever works for you. So f prime of x, that's going to be my derivative of the top. So my top function is g. And then my bottom function h minus my top function g times the derivative of my bottom function h, all over my bottom function squared. So h squared. So let's find g prime. So the derivative of x, that's just a linear function, or you can also think of it as 1 times x, which is just 1. And h prime, Same thing, I have 1 as the derivative of x, and then the derivative of 20 is 0. So actually the derivatives are the same here. So now we can go ahead and use our formula, f prime of x. So I want g prime, which is 1, times my h, which I defined as the bottom function, minus g, which is x, times h prime, which is 1, all over h squared, which is this x plus 20 squared. So let's look on the left-hand side which one of these options looks like this. So notice what I was saying in the last slide is that I have this subtraction here. So that means that the order does matter between this term and this term. So you can't have them backwards, which I think you'll notice is kind of the big difference between these two, right? You have the x times 1 here for these two, but then x times 1 here for these two. So notice that the order does matter because we're doing subtraction and not addition. If there was addition there, then these would all be equivalent, basically. But anyway, so that kind of limits us to C and D, right? And if we're looking between C and D, the only difference is what's in the denominator. And so the denominator should be h squared, so D is our answer. And then for the second part, we just need to simplify this a little. So multiply these two together, I get x plus 20. Multiply these two, I get minus x over, and then you can leave the x plus 20 squared like that. You don't have to multiply it out. These x's cancel, right? X minus x. So I'm left with a 20 over x plus 20 squared. And that is our derivative. All right, let's try one more with the quotient rule. So again, let's label it G, H, T, B, whatever your two favorite letters are. It doesn't really matter as long as you have the order correct. So f prime of x, that's going to be g prime h minus g h prime over h squared. Let's find g prime. My g in this case is this x, so again that derivative will be 1. H prime is this x minus 32, so I have 1 minus the derivative of 32 is just 0, so just 1. Alright, so f prime of x is the derivative of g, which is 1, times h, which is x minus 32, that's what I defined here, minus g, which is x, times h prime, which is 1, all over h squared, which is this x minus 32 squared. Alright, so let's just simplify the numerator a little, and you should get something like this. And then I have x minus x, so these kind of go away, and I'm left with negative 32 over x minus 32 squared. Alright, so let's do 2 last problems. It's kind of a little bit of an application. So we have f of x here. Kind of already looks like there's a product going on, so I might need the product rule. I want to know the derivative, and then I want to find the equation of the tangent line. So that's kind of applying the derivative. Alright, so again, kind of like I hinted, we have 2 plus 5x times 5 minus 4x. It's because I said times and there's an x on the left, an x on the right. That means we need the product rule. So I'm going to call this my g, I'm going to call this my h. So f prime of x, you might already be getting tired of me saying this, but g prime h plus g h prime. So hopefully as you get more practice, these formulas will become second nature, but if not, you can always refer to them in your notes or the textbook. G prime, so I have 2 here, that's going to be 0, right? The derivative of 2 is 0, plus the derivative of 5x is just 5, so my G prime is 5. Let's find H prime. So my H I have is 5, its derivative will be 0. And then I have a minus 4x, so minus 4. So these are my 2 derivatives that I need. F prime, so I need my G prime, that's 5, times my H, 5 minus 4x, plus G, that's 2 plus 5x, times H prime, which we found to be negative 4. Be careful with the negatives here. Now let's just distribute terms, add them up, simplify, all that good stuff. So we got there, and then minus 8 minus 20x. So I get 25 minus 8, right? That gives me 17. And then this minus 20x, that gives me minus 40x. And so that is our derivative here. Right, for the second part, we want to know what the tangent line of the graph, or to the graph at x equals 1. So what a tangent line is, we might have a graph that looks like this. I don't know, I'm just making it up here, and then this is 1. So our tangent line is this line that touches the graph at this point 1 and has the same slope or the same derivative of f of x, this purple curve. So this means that I'm going to have a line, y equals mx plus b, right? And we're saying that the slope of this line is going to be equal to the derivative of the graph at that point, x equals 1, where it touches. So we want to find f prime of 1. And to do that, all we need to do is plug in 1 wherever I see an x in my derivative that we found in right here. So 17 minus 40, and substituting that 1, and I get minus 23. It's totally okay that it's negative, right? Because it's just going to be a slope that's going downwards from left to right. So don't worry if it's negative, because that's a possibility. So my line looks like y equals negative 23x plus b. And so most lines, they have a y and an x, but then I have this b, this unknown b. So you remember how we find this is called a y-intercept, right? So what you can do is you could find an ordered pair for x and y, plug them in, and then solve for b. And this ordered pair for this tangent line is actually going to be the point at x equals 1. So I want to find the corresponding y value, or f of 1, right? These are the same. So to find f of 1, we're going to go back to the original function up here and plug in 1. So wherever I see an x. 4. Alright, so we can simplify, that becomes 7 times 5 minus 4, which is 1, so just 7. So that means I have the ordered pair 1, 7. And so now we have everything we need to solve for b, right? I'm going to plug in 7 for y is equal to minus 23, 1 for x, plus b. And if I want to solve for b, I'm just going to add this negative 23 to the other side and get 30. All right. And then our very last step is just forming our line, y equals mx plus b, right? So we have the slope of negative 23, and we just found that the y-intercept is 30. So that is the equation of our tangent line. When you put the answer into MyLab, you only need to include whatever's to the right of this because it has y equals. So when you put it in here, it should be negative 23x plus 30. Okay, so just be careful of how you're answering the question because it might count it wrong if you're including the y equals. All right, let's do one more. So now we have a quotient, right? I have this kind of fraction bar here, or you can read it as x minus 5 divided by 8x minus 9. Either way, you should know that you should use the quotient rule here. So I'm going to put g over h. Let's use our rule. That's g prime h minus g h prime over h squared. Let's find g prime first. So for g, I have x minus 5. So the derivative of that is just going to be 1 minus 0, right? H prime, I have this 8x. That's going to give me an 8 because 8x is a linear term. And then minus 9, that derivative will be 0. So here are the two derivatives that I'll need to form the derivative of the quotient. So g prime is 1. I called h to be 8x minus 9 minus my g, which I call minus 5, x minus 5, times h prime, which we found to be 8. And this is all over h squared, so 8x minus 9. Do a little bit of simplifying. And I get 8x minus 40 squared, 8x minus 9 squared. And then just be careful with the negatives. 8x minus 8x is 0. So these two will go away. And then I have minus 9 plus 40 because I have a negative over here. So minus 9 plus 40 is 31. Okay, so I have 31 over 8x minus 9 quantity squared. And that will be your answer for the first part. For the second part, it's very similar to what we just did in the last question. I want this y equals mx plus b. At this point, x equals 1. So to find m, that's just going to be f prime at my point 1, which is given in the problem. It might be a different number in other problems, right? If this was at x equals 3, then I'd be plugging in a 3 here instead. But anyway, f prime of 1, so I'm going to plug in 1 into my derivative wherever I see an x. So I get 31 over minus 1 squared, which is just 31. So I have almost complete tangent line equation, except I have this y-intercept that I don't know. But we can find that real quick by finding an ordered pair xy at x equals 1. So f of x, I want to know the y value corresponding. I'm just going to plug in 1 wherever I see an x in my original function up here. 8 times 1 minus 9. So I have minus 4 over minus 1. So I have a y-intercept of 4. I'm sorry, not a y-intercept, my y value of 4, giving me a 0.14. And so now I can plug that into my partial equation. So y is 4, 31 is my slope, my x value is 1 plus b, and now we can solve for b. So I have 4 minus 31. I'm going to move that 31 to the other side to isolate b. And so b is negative 27. And the very, very last step, don't forget to do it, is answer the question. Y equals 31x minus 27. And it's minus because our y-intercept was negative. All right. And remember when putting it into MyLab, since it says y equals, all you have to put is the 31x minus 27. Alright, so that's the end of 10.3, and I'll check in with you about 10.4 in the next video.